So this was the handout that we were working on. And again, you guys have this available in D2L. So we looked at the examples that were already in the handout, but now we are working on these problems over here. So like I said, you already have the link for the Google Sheets, but I just shared that with you on the Zoom chat. So you should have that. But basically, we worked on example 1. So we were talking about, you have this restaurant bill of $43.50. You're paying a 6% tax on it. So what would your total be? And then if you add a 15% tip on your bill, what would that come out to be? So we had a little bit of discussion of, would you pay the tip after you've calculated the tax, which is kind of how your bill shows up to you anyways, is they add the tax to you and give you the total amount. So would you do the tax on, the tip on the total bill, or would you do it on, for your, basically your food and beverages? So that's why we have 2 different calculations over here. The dollar amounts in yellow is basically if you used the total bill to do your calculations. So that's what come out to be. But if you calculated your tip only based on what your restaurant bill was, then this is what your tip would come out to be, which means when you are calculating your total cost of dinner, that would be the $43.50 for the restaurant bill, the $261 for the taxes, the $653 for your tip, and then that's what this total would come out to be. So you can just see there's going to be a slight difference in your dollar amount depending on what you use to calculate your tip on. So this is how far we had gotten on Wednesday. So let's get into our second example now. So this one is talking about a vacuum cleaner costs the dealer $320. So this is the price that the dealer is paying for it, but then they are selling it for $699, and we want to know what the percent markup is. So again, you can see here's your formula for the percent markup. You take your selling price and then subtract the cost from it, and you're always dividing by, what the original price was, which in this case would be the cost. And then of course, we're converting that into a percent because you are talking about a percent markup. So remember, part of the assignment here is getting comfortable working with spreadsheets also. So that's what we are doing over here. And again, if you guys did not see, I'm sending that link one more time. So here's the link for this spreadsheet that we're going to be working on. So you should see that coming through on your Zoom chat, guys. So what you're going to be doing here, if you look at the bottom of this document, you will see on the bottom your names are there. So we've got the same exact thing for all of you guys here to work on. So you've got your, just go click on your name and you can work on this simultaneously. So you are also getting practice of how to work with spreadsheets and how to type in your formula. So in this case, we are talking about figuring out what the percent markup is going to be. So, again, your formula for this is you take your selling price, subtract the cost from it, and then you're dividing by your cost again. And then, since if you're going to be typing all of this in at the same time, which is what I would do, go ahead and put that subtraction in parentheses so that, the calculator, the built-in calculator knows they need to subtract first before they do the division. So it looks like some of you have already done this, but those of you who have not done this calculation, go ahead and let me see what your value is coming out to be. So since some of you had to leave early on Wednesday, you probably don't have problem number 1 done, but go ahead and start working on problem number 2. So let's see, I'm seeing Kendall, Destiny, and Terry. Looks like you are the only ones who are in here. So Terry, it looks like you actually did the subtraction, and then after that you did the division. So I do see your percent markup in there.
It seemed really high to me.
Well, but think about it. I mean, they did almost double the price of the vacuum cleaner though, didn't they?
Yeah. Question two, you said that you use the parentheses to create that problem within the cell.
Yeah, so what I would do is, once we are in that box for the percent markup, just do equal to. You can do open parentheses, and then here where I've already typed in the dollar amount, so you would be taking that $6.99 cell, so click on that, minus the cell where you have the original cost, which was the $3.20. So we can go ahead and do, which looks like a cell D14 minus cell B14. And then you close your parentheses once you've selected those two cells. And then you're dividing by the original cost again. So you would click on the cell which has the 320 again, and that will give you that formula of selling price minus cost divided by the cost. So by default, it is going to give you a decimal answer because that's all we've put in there. And then you can go under format on the top menu, click on number, and this one is going to be a percent. So just click on percent and it automatically converts that into a percentage for you.
Okay. Okay, so what did you do? You went to format and then
Format, and then under number,
and then percentage.
and then percent. Yeah,
Okay, I did that, and you can see my work's kind of underneath it, but
I did see that. Yeah,
Okay, thanks.
yeah. So I saw that you did the subtraction between the two values on the top, and then using that as your calculation, you divided by B14, which was your 320, and then you converted that into a percent. Yeah, exactly like that. Give me 1 second, guys. I think the pest control guy is over here. 1 second. Okay, so anybody have trouble kind of putting that formula in? And here's the thing, guys. The reason I am asking you to do this because the homework assignment that goes along with this is going to be pretty similar to what we're doing right now. So I want you guys to be able to do your cell references, using the built-in calculations, formulas to do the math. Because, it's kind of nice to have those skills of how to use spreadsheets, and this homework assignment, this little handout kind of gives us that opportunity that we can, work a little bit with spreadsheets. So that's why I'm kind of asking you guys to work along with me, so that way any questions come up, anything that doesn't make sense, you can ask me while you are here, in class with me, obviously. All right, so as you guys can see, once you do that little calculation, selling price minus the cost, and then divide that subtraction by the original cost, convert that into a percent, you can see it comes out to be approximately 118%. And if you wanted to put this into a whole number and not keep the two decimals, you will see on the top over here where you have those decimals with zeros on them. So that can increase the decimal places or decrease the decimal places. If you wanted to decrease it, just go 2 places, decrease. If you wanted to increase it, then you use the one on the right and it gives you more decimal places. So that's kind of how you can do those little decimals. Okay, so Sabrina, you're talking about getting a little confused. Let me see if it let me open your screenshot that you sent me. Okay, it really doesn't show me what the error is about. You actually don't need to use the word divide, Sabrina. You can literally just use the backslash. So instead of, where you have divide, just use the, forward slash, and that should do the trick. So maybe that's why it's giving you the error, because it's not recognizing that word divide in the middle of the formula. So just use the forward slash, and I think that should quickly fix your error over there. Thank you. So you can see in, I don't know if you guys are able to see my screen as you're working on your own, but you will see over here that that's kind of how I typed in my formula, which you should be able to go, over to the tab where it says instructor copy and see the way I'm typing in my formulas. And then remember, we're just using the formatting to convert it from a decimal answer to a percent answer. So this is a percent markup of 118%. So as we were discussing, I mean, that's a pretty big price increase. And you can see that they have, 320 as their cost, but they're selling it for more than double that. Okay, anybody questions on number 2? Okay, so we've looked at how to work with sales tax, how to work with tips. Now we did the percent markup. Our next one over here, we're talking about a salary increase. So we're talking about how Mark's present salary is $36,500 and he is getting a 7% raise. So we want to know what his new salary will be. So in this case, we kind of have to think about, they're not asking us about, how much his raise is going to be. They want to know what his new salary is going to be. So any ideas on how we can calculate his new salary? So we know his original salary is $36,500. We know he's getting a 7% raise. How do we calculate his new salary? So if you were just doing this, by hand, normally using a calculator, what would you have done?
Wouldn't you find out what the 7% of his salary is? So you divide it by the 7% or 0.07.
Okay, so let me open my calculator here. So we're taking 36,500 and dividing it by 7%, which we would write that how?
0.07.
Yeah, very good. Always convert your percents to decimals. So when you divide it, it's actually giving us 521,428 and then some change after that. So what went wrong here, guys? Because to calculate our raise, do we need to divide by 7% or do something else?
Multiply.
Okay. Let's change that to multiplication. So 36,500. And again, same thing as a decimal.
Yes.
Okay, and then what would we do to calculate his new salary?
Then wouldn't, oh shoot.
Oh, you're almost there.
Wouldn't you add the to his regular salary with the new one?
Very good. So you would take the 2,555 and add that to 36,500. And that's what his new salary will be after he gets that 7% raise. Now, the question is, how can we do this, in Excel or Google Sheets in our case here? So very simple again, guys. You are taking that 36,500 and yeah, we are multiplying it into the 7%, but because we need to add that 7%, whatever that dollar amount comes out to be back into the 36,500, you will actually multiply this with, you basically take the 7% and add 100% to it, because that 100% represents the original salary he has, the 36,500. So you actually multiply by 1.07, and you can see when we do that, it's going to give us the same value of what we had here, which was the, hold on, the $39,055. Or what I'm going to do, because we're going to have to modify this a little bit for Excel, you can actually do 1 plus 0.07. So there's multiple different ways that you can do this. Now, since we're doing this over here in this little, what his new salary will be, that's going to be equal to, I'll click on the cell where we have his 36,500, and then you're multiplying that by 1 plus that, or you can just type in 1.07 and you will basically get the exact same answer over here. So you can do cell reference for the 7%, or you can do the B20 where his 36,500 salary is, multiply that with 1.07. So instead of having to break it down into two calculations where you multiply by the 7% first and then go back and add it, that 2,555 back into the 36,500, if you do the 1.07, it takes care of that addition on its own. And then again, we'll go under format, go under number, and you can check accounting, currency, any of those, and that will change that to a dollar amount. And again, you can leave it as 2 decimal places, or you can decrease your decimal places and just leave it as a whole number. So it really doesn't matter. Normally with dollar amounts, we try to leave it at 2 decimal places. So in case you do have any cents, you can kind of see what that comes out to be. So how do you work the math? And then basically, how would you put that in your Excel worksheet over here? So again, very similar to honestly how we calculated our tax and tip over here was the same way, except they broke it down into 2 different parts. They just wanted to find out what the tax was, and then they wanted to find what the total bill would be, including the tax. So that's why we didn't worry about multiplying by 1.06 or multiplying by 1.15, because they did want us to break it down into 2 separate. Here, they didn't ask us, what his raise was going to be. They just asked us what his new salary was. So that automatically tells us, we're adding up those numbers to get our answer. Questions on this one over here, guys? Okay. The next one we're talking about, a furniture store has a table that is $115. It is on sale for 15% off. So what is the price of the table after the discount? So again, they didn't ask us, how much are we taking off on that $115? They just want to know basically what the new price will be once that 15% discount is taken off. So how are we going to do the calculation for this one? Because this time you are not adding, but you are subtracting. So the original price for the table is $115. It's on sale for 15%. So what is the new selling price going to be? So think about again how you would do the math for this just, regularly. Kendall, Sabrina, Brooks, any ideas? Okay, Terry, I see your answer. Destiny, sure, you can try that, not a problem. So how would we calculate our 15% discount on the value of this table? Okay, I was gonna say, Destiny, your numbers are looking larger. Remember, since that's a discount, right? We have to be going down. Well, you're still calculating 15% on top of the 115. So you're obviously still going to be taking your 115 and multiplying it with the 15%, which in this case would be 0.15. And that will tell you how much you're going to be taking off. So you would, it's coming out to be 1725. So that's what you would be subtracting from 115. And I'm just doing this in the opposite order, so it'll give me a negative answer, but obviously it's dollar amount, so it will be positive. So we know our final value has to come out to be $97.75. So the idea is now, how can we do that with how would you type that in Excel? And again, there's multiple different ways. You guys might have a different thought on that, but basically 100% is the original value of the table. You are taking 15% off of it. So if I take 100 minus 15, that means after I have taken the discount, I will be left with 85% of my original value. So you can again go in here in your price for the table after the discount. I can click on 115, the cell where I have 115, and then you can multiply. And again, in parentheses, you can do 1 minus the 15%, or again, you can just type in multiply by 0.85%, and you will obviously get the same result. So it's up to you how you guys want to work that in. And then, of course, go into format and again, choose either currency or accounting as the formatting. So again, it will rewrite that as a dollar amount for us. So the difference between the previous example and this one, in the previous example, Mark was getting a 7% raise. So you will see when we calculated, we actually had the dollar amount for his current salary, and then we did 1 plus the 7% so that he got that, added onto his salary. Now with the table example, since we were doing a discount, obviously that means the price goes down. So here we ended up doing the dollar amount for the table, and then we multiplied it by 1 minus whatever your percentage was. So you can see when it's an increase, you are adding. When it's going to decrease your value, you are subtracting. Question on this one, guys?
I had a question about something a little bit earlier, but I
Yeah, go ahead.
forgot it. When we were doing multiple steps, can you do a formula in the cell that is a multiple step? As long as you're putting parentheses around the things that are supposed to be done first?
Yes.
Okay.
And sometimes it may just take a little bit working around just to see, if you're getting the right answer or not. But yeah, you can definitely do, parentheses make such a big difference because then it tells how exactly you want it to be calculated.
So can you have more than one set of parentheses within a problem, or does that confuse the cell?
I mean, you can do multiple. It really just comes down how you've written it down. And so a lot of times, we would actually have to look at the very specific example and see how you're arranging it in what order. So if you have something in mind, we can kind of work through it for sure.
I'll work on that one with you at the end. I don't want to hold up class.
Okay.
It was a question I had forgotten about.
Okay. Yeah, no worries. And I've been looking at your answers here, guys. And yeah, definitely you guys were on the right path with this. So Sabrina, was looking at the one where you had the B26 minus that, and that should also work because that will give you the same answer. So yeah, very good. That would work perfectly. Kendall, yeah, very good. Your answer would also work. And then Terry, Sabrina just shared an answer with you through chat. So you should be able to look at that. Yeah, Kendall, 97.75 is what it should come out to be. All righty, perfect. Very nice. And then our next example is talking about a commission in this case. So they are basically saying you are a salesman and receive a 21% commission on your sales. So your commission is $539. How much did you sell? So I want you to think about this a little bit and tell me, what does that 539 represent? So you're a salesman and receive 21% commission on your sales. Your commission is $539. How much did you sell? Because, you know, when you are a salesman working on commission, the idea is if you make a sale of, you know, whatever big item, small item, based on that, your commission is calculated. So in this case, of course, they're saying that this person, or I guess that's us, we received a commission of 21% on our sales. And they're telling us our commission was $539. So how much did we sell? So how would the math for this work out? What does that 539 represent?
Would you have to find out what the total amount obviously is, and would you multiply 539 by the whatever, the 79%?
Okay, Sabrina is saying you divide the commission by the rate, okay? And then Terry, you're thinking our sale, whatever sale we made should be the remaining, what was it, 79% of that?
Yes, it sounds wrong though.
It sounds wrong. Okay, let's see what Sabrina had to say. So she was saying you take your commission, which is the dollar amount. So basically what's happening over here, let's do this 1 second. What's basically happening here is this 539, which is the dollar amount, is basically the equivalent of that 21% commission that you are getting on your sale. So, you know, whatever item you sold, whatever that dollar amount was, you're basically calculating 21% on that. And that's where the 539 comes from. So yeah, Sabrina, as you were saying, if you take your, which, you know, in decimal, this would be 0.21. If you take that commission rate and divide it by 539, that should work. So let's see what this comes out to be when we do the math. So you're taking 539, not 5,000. 539, and we're dividing it by 0.21, which looks like it's coming out to be $2,566, and rounded, that would be 67 cents. So Terry, let me ask you this. If you wanted to go the 79% route, what would your math look like for that?
It would have been multiplication versus divide, but Sabrina's makes more sense. I was doing that earlier with another problem.
So just multiplying 539 with the 75% would not work. So what else would we need to do then? Because it will work that way. Your math will just look a little bit different. With what Sabrina said, that's definitely more straightforward, because we know the 539 is basically the dollar amount for that 21% commission. So you and I can kind of take a look at that later if you wanted to see what that math looks like, because it will just be a slight bit different. But yeah, the best way to do this would be take your dollar amount, divide by the percentage, and you will come up okay. Is my screen not showing? Oh, okay, sorry, I didn't realize my screen was not showing. So yeah, that would be what kind of math we are doing. So if we are on the worksheet over here, then basically we'll just come over here, yeah, and then divide your dollar amount. And you can actually use the cell reference in this also, because we have written these guys as percentages, so you will automatically be able to get that conversion taken care of. And then again, guys, just go ahead and format your cell into currency or accounting so that you can get your dollar amount. So that's taking your 539 and dividing it by 21%. So basically the item he sold for was worth about $2,500. And then based on that, when they did the 21% commission, this is what he got, the 539 as the additional amount. Questions on this one, guys? Okay, so this was basically trying to work with percentages, you know, trying to see how, when you need to add, when you need to subtract, how to kind of make those adjustments. So all 5 of these examples were trying to show you how to use percentages in a different way. Now, one of the other things that we want to talk about related to these applications for percentages is budgeting. And we were kind of talking about this last time, is where, you know, when you're working on budgets, and we're doing this as a monthly cash flow, we basically want to make sure all our dollar amounts are converted on a monthly basis. So if it's an income, if it's an expense, make sure instead of being a year or weekly or, you know, whatever the case might be, we're converting all of them into monthly expenses or income. And then we can add up our total income, add up the total expenses. And when you subtract the two, it gives us, you know, what the cash flow should be. And as we saw last time, Betty here was definitely living far ahead of her means because her expenses were, you know, quite a bit ahead of her income. So our example here is, you can see we've got 3 different sources of income listed over here, and then 4 different types of expenses. Some of them are listed as monthly, but then some of them are listed as yearly, weekly, you know, 6 monthly, and that kind of thing. So let's convert these amounts into monthly first before we can calculate what our total income and total expenses are going to be. So I've already included the original values over here in the table. And then underneath that, we're doing the breakdown where we will be converting all of this into a monthly basis. So our job is already at $600 a month. So we can just go ahead and type that in. And you know what? I'm going to go ahead and pre-format all of these cells into accounting, so we know all of them have to be dollar amounts here. So I'm just going to go ahead, select all of them and convert them to accounting. So as we type our numbers in, it will automatically convert them into dollar amounts. Now, our college fund was also given to us on a monthly basis. They're telling us that is $400 a month. So again, we don't need to convert any of that. Now, the scholarship is given to us as $5,000 for per year. So how do we break that down into a monthly value? So they're telling us she is getting $5,000, or whoever is, I guess they didn't really tell us the person. This person is getting $5,000 a year for scholarship. So how do we convert that into a monthly income?
Divided by 12.
Divided by 12. Very good. So yeah, we're going to take our 5,000 and divide it by 12. And does everybody know why we're dividing this by 12?
Because we're trying to find out how much it'll be a month rather than a year, so it wouldn't be 365, because that's how many days is in a year, whereas there's only 12 months in a year.
Yeah, very good. So since we need to figure out how much this person would be getting on a monthly basis, you would be dividing it by 12 months. So that's why the 5,000 is divided by 12. So you can see, again, as a rounded value, it comes out to be $416.67. So we have all of our income. So for adding up your income, remember we had talked about you can use the sum function, SUM. So you can use the sum function and then basically go ahead and select all those 3 cells. And you can close your parentheses, hit enter, and it will do the calculation for you. Or you can click on each cell individually and put the plus sign. But why do that when you have the built-in sum function, right? So just use the sum function. And we can go ahead and add up. And again, we'll need to format this into a currency or an accounting so that it will automatically round it up for us into 2 decimal places. So as you can see, her total income comes out to be $1,416.67. So now we need to figure out what her, well, I keep saying her, what this person's expenses are going to be. So again, make sure you're cutting it down to a monthly basis. So rent again is given to us as $450 per month. So we don't need to do any calculation there. But then the groceries are given to us as $50 a week. So how can we convert that into a monthly expense? $50 a week into a monthly expense.
Multiply it by 4.
Very nice. Yes, because we assume on an average there are 4 weeks to a month. Yeah, very nice, Sabrina. Very good, guys. So yeah, we will be taking, so over here I'm going to take my 50 and multiply that by 4. And remember, again, for multiplication, guys, we use the asterisk symbol. So 50 times 4, of course, tells us that grocery expenses are $200 a month. So that's taken care of. Now for the tuition and fees, they're telling us it's $3,000 for 6 months. So what does that come out to be on a monthly basis? How do we calculate that? Tuition and fees, $3,000 every 6 months. Carrie, yeah, very nice. So we need to again figure out how much they're paying on a monthly basis. So you will take your $3,000 and basically divide it by 6 months, right? So that will give you how much they are paying each month, which of course comes out to be $500. And then same thing for the incidentals, they're telling us it's $100 a week. So how much will that come out to be on a monthly basis? Yeah, because again, like you did for the groceries, you will multiply that by 4. So you are taking 100 times 4, and that will become our monthly incidentals. And same thing, to calculate our total expenses, you can use the built-in sum function. So equal to sum. And then we're again going to select all 4 of those cells, close your parentheses, and it will do the calculation for us. And again, I'm going to format this into a dollar amount. So monthly expenses are $1,550. So what do you think her this person's cash flow looks like? What do we do to calculate the cash flow? And I'm going to go ahead and format that into a dollar amount also before we do the math. Okay, Terry, yeah, thank you. So we are subtracting which number from which number? Very nice, Brooks. Yes, it's going to be income minus the expenses. So income is 16.67, and then from that we are subtracting the expenses of 1550, which of course tells us, and you will see because I formatted this as an accounting value, since it's a negative number, it puts it in parentheses. Let's see what happens if we use one of the other formattings. I've never actually tried that. If we did currency, it's actually showing you as a negative sign in there. So, whatever formatting you use, it is going to try, I think if we did financial, it's probably going to do parentheses also. So parentheses is what we kind of use in accounting and, any kind of financial calculation, but if you want to leave it as a negative sign, then convert it to a currency formatting. So obviously they either need to find another source of income or they need to cut back on some of their expenses, right? Because again, their monthly cash flow is negative, which means they're living beyond their means. So that's kind of how that budgeting example comes out to be in this way. So this is not really technically a percentage application, but it's definitely kind of following that theme of, how to work with our financial math calculations. Questions on this example over here, guys? Okay, so let's get into what your homework looks like for this specific assignment, which is for your applications of percentages. So if you go to the bottom of your chapter 2 module, you will see this is where I have the homework assignment. And you know what, let me put this in student mode, otherwise it's not going to show it the way I wanted to show it. So we'll click on this, and this is what you guys should see. So we're basically working on similar types of examples that we just did in our handout. So you've got your, calculations based on discounts, on, taxes, percent markup, and those kind of similar examples that we did, and then one example on budgeting. So the due date for this is going to be a week from today. That's going to be next Friday, the 30th. I've given you a template to work on this. So when you click on that, your template will look very similar to what we just did in our handout spreadsheet. So again, very similar setup. You've already got your prices listed over there, and then you're calculating, whatever the original amount or discounted value or total bill, those kind of things are. So you should be able to follow kind of the similar setup that we did for our handout with this one over here. So again, guys, since we are doing this as a spreadsheet, I do want you to be able to do your cell references, try and use your built-in operations. So that way I kind of know that you are feeling comfortable working on spreadsheets, because again, when we get into our statistics chapter, we will be working with spreadsheets even in that chapter over there. So, this is a good starting point to start getting comfortable working with spreadsheets. And I know some of you have had experience and some of you are kind of new to it. So this should be a really good assignment to try and get comfortable with spreadsheets. So that's what you guys will be doing, and you have a week to work on this. So this is part of your homework for applications of percentages that you guys will be working on. So any questions before we move on to our next topic? All righty. So if you go back to the chapter 2 module, you will see I included the geometry handout. So you've got the perimeter circumference handout and the area and volume handout also. And this is actually another textbook that we are using. This is also free, so you guys don't have to pay anything for this. So it just links you directly to those sections from the textbook. And then also, let me show you very quickly. Under our OER textbook module over here in D2L, if you go under the OER textbook, you will see I've also included the textbook over here as the HTML link and also as a PDF file. Now, I think the PDF is a slightly older version because this topic actually shows up as chapter 9 in the textbook. So when you look at the context, you will see our measurement and geometry chapter is actually chapter 9, and that would be sections 9.5 and 9.6. If you were, wanting to download the textbook, that would be chapter 9 in this case. And then of course here, it takes you directly to the link for the perimeter and circumference and area and volume. So what we are going to be doing is just reviewing some of these basic formulas for perimeter, circumference, area, and volume. And once we're comfortable with that, then we'll do examples on how we can do cost estimation based on, these dimensions of, whatever room or wall or window, whatever we're looking at. So they're just talking about how we can have, polygons, and polygons basically mean a figure which has, many sides. And they're talking about how polygon is a closed figure, and it's going to be flat, so kind of like 2-dimension, whose sides are line segments, which means your edges, your sides are going to be straight lines. When you have non-polygons, basically that can be anything, as you can see in these examples over here. So Sabrina, if you go under your chapter 2 module and then click on this supplemental handout for perimeter and circumference, it will bring you to the page I'm on. So you can download the textbook if you wanted to, but if you just want to look at the page that I'm looking on, just under chapter 2 module, just click on the perimeter and circumference handout. So remember, polygons are going to be closed figures that have line segments or straight lines for their sides, and then non-polygons will be anything that's not a closed figure, or basically figures that don't have flat sides, straight lines. So when we talk about the perimeter, obviously we're talking about the distance around your polygon. So we are talking about, if it's a rectangle or a square, you take all 4 sides and you add them together, right? If it's a triangle, you take all 3 sides and add them together. So as simple as that, some of them we convert into formulas, and some of them, there may not be a formula. You just take all the sides of your polygon and add them together. So look at something like this here. This is a rectangle. And we know it's a rectangle because your opposite sides have the same measurement. So you're taking all 4 sides and adding them together, which if I had to put a formula on this, we can say twice the length, because both the lengths are the same measurement, plus twice the width, and that would be these 2 widths, because again, they are the same measurement. So that would be a formula for your rectangle. And obviously we would still get the same result, because you would be doing 2 times 5, which would be 10. And we would be doing 2 times 2, which would be 4. And 10 plus 4 would still give us 14 centimeters. So obviously you can see this can be done with or without a formula. But then you look at a shape, something like, we have down here, which is pretty irregular. So we didn't really have a formula for this. But again, all you do is take all, what is this? 1, 2, 3, 4, 5, 6 sides, add them all together, and you would get the perimeter for this shape. And we know, in real life, in homes and office spaces and, malls and shops and whatnot, we don't always have nice, clean, rectangular shapes, because depending on, what space they had available, how they're going to construct something, everything can have a very irregular shape to it. But we should be able to follow a lot of these ideas and come up with a perimeter. So, just another different shape over here, which I thought this was an interesting example, because as you can see, not all the measurements are given to us. So this side is missing, this little side is missing, this little side is missing, but we have enough information that we are able to gather the missing values and still find the perimeter of this shape. So let's take a look at this guy over here. So they're naming it as A, B, and C for the missing sides that we don't have a calculation on. And they're showing you how they came up with that. But let's talk about how did they come up with that. So we know this entire length is 12 meters long. So we know same thing here. This guy has to be 12 meters long. So if this is 12 meters, but then this little section over here is 2 meters. So you can see we do 12 minus 2, which gives you 10 meters. So this little section, you know, which is going from here to here, comes out to be 10 meters. Does that make sense? Yeah. Okay, then side B on this little section over here. So then for side B, you know, they're telling us this entire distance is 9 meters. So that goes from here to here, but then this little section over here is 1 meter. And this is, of course, below this line. So that's the additional distance of 1 meter. So that's where that 9 plus 1 is coming from. But then, however, this little section, which is this distance, is not part of side B. So you are having to subtract that little distance, you know, from this 9 meters over here. So that's where you end up subtracting the 2. And you are coming up with 8. So yeah, Brooks, that should actually be 8 meters for side B. So again, basically, and you could kind of do this in a reverse order too if you wanted. So we know we are not using this little section, so this is gone. So instead of 9, you know, you subtract 2 and you're only using 7 meters from here, which would be this distance. So this distance here would come out to be 7 meters, and then you add that 1 meter to it, and you would still get the same answer of 8 meters. So that's the B side. And then the last one is C, which is, of course, this distance over here, which again, very straightforward, since we know this entire distance is 12, but we're not using, you know, this section over here. So you subtract the 1 meter from there, and that's what gives you the 11 meters. So once you have those missing sides, then, you know, of course, you can go ahead and calculate the perimeter. So that would be 10 from here, you know, so 10 from here, 2 plus 2 plus 9 plus 11 plus 1 plus 1 plus 8, put all of those numbers together, and what do we come up with? 44 meters. So you don't have to be given every single side, but you know, if you are going to have a figure like this, and the important part here is, guys, part of that is kind of an assumption, but we are making the assumption that those corners are 90-degree angles, and that's why we're able to translate, you know, those measurements like we did. So just to make sure that we can get comfortable with this, let's take a look at some of these examples over here with the perimeter. So this is, of course, a triangle. So what will the perimeter of this triangle come out to be? Terry, all right, very good. I see your answer. Brooks, very nice. So we are taking 3 plus 8 plus 9. So what does that come out to be? Let's see, that's 11 plus 9. So yeah, very nice. And since they're giving us the unit measurement in feet, this will come out to be a perimeter of 20 feet. Okay, this little guy over here, you know what? Let's save this before I move down. Does anybody know what shape that is? Yeah, rhombus is what, any four-sided figure, but this one actually is more like a trapezoid because of those slanted sides that it has. I think rhombus, you know, I will have to look it up. I'll have to see what the exact definition for a rhombus is. So anyway, this is a four-sided polygon. So what will our perimeter for this guy end up looking like? Okay, Terry, I see your answer. Anybody else? What will be the perimeter for this guy? Guys, if you don't participate, there's no way for me to know if you're understanding this, if you are working on some other assignment, if you are, I don't know, watching another video. I mean, I know how to do this, man. This is not for my benefit. Okay, Destiny, I see your answer. And again, guys, since our unit of measurement was meters, you do want to make sure you're including that unit of measurement with your answer. But yeah, very nice. 26.8. Kendall, I see your answer also. Oh, let's save that before I move. And then here again, you can see one of those irregular shapes. Okay, Brooks, very nice. Thank you. So again, one of those irregular shapes, but it looks like they've actually given us all the measurements on the side over here. So we just need to go ahead and figure out what our total perimeter is going to be. And this one is going to 2 decimal places. And this will, of course, again be in miles. Okay, I see your answers coming through. Alrighty, I've got okay, I've got Brooks's answer, Destiny, Terry, and Kendall. Yeah, and Kendall, I would just say leave it at that 2 decimal places, since that's what our each of the sides were given in. So this would be 49.89, which is what all of you guys came up with. And again, in miles. So remember, there are formulas for perimeters, but as long as you understand the idea that you take all sides of your polygon, you know, whatever that shape might be, and add all the sides together, that gives you a perimeter. And you know, one of the applications for perimeter you can think is if you're going to be putting you know, a fence around something, right? That would be the perimeter that we would be. If you're building a wall around, you know, your home, or you know, whatever the area might be. I'm not really sure if there is a official name for this shape. I mean, I'm sure it resembles something, but I am not entirely sure if there's officially a name for it or not. And you will see they talk about show solution. So they basically just give you the final answer in here. They're not actually showing you, you know, how to calculate this. It just will show you the final result. Okay, so when we talk about polygons, we talk about a perimeter. Now, when we talk about a circle, you know, we talk about a circumference, but it's basically the same idea, right? We want to know what that distance around the edge of the circle is going to be. So 2 numbers that we need to be familiar with when we're working with circles is, you know, of course, where the center of your circle will be. And in this case, if you're not going to put it on top of a coordinate plane, like an X and Y coordinate axis, then even the center sometimes doesn't matter, but you definitely need to know what the radius is going to be. And if you double the radius, you get the diameter, or if you take the half of the diameter, you get a radius. And you can see that in the figure that they have over here. So we're saying a diameter of a circle is any line segment that passes through the center of the circle and has its endpoints on the circle. So basically, the diameter has to pass through the center, and its endpoints basically have to be touching, you know, the edges of the circle. Your radius would be a line segment that basically goes from the center of the circle to one point on the edge of the circle, right? So the radius is just going from the center to a point on the circle. And literally, the radius is the diameter divided by 2, or the diameter is 2 times the radius. However you want to think of that relationship between the radius and the diameter. Also, another number that we need to be familiar with when we're working with circumference and area also for a circle is the number pi. Now, we define pi as approximated at 3.14, but it actually has decimal places, which has been figured out to, I'm trying to remember the last time I looked at this. I know they had reached 6 million decimal places, but I think they're higher than that now. But basically, it's a non-terminating and a non-repeating decimal for the pi. As a fraction, sometimes we represent pi as 22 over 7, but as a decimal, we normally represent it as 3.14. And I think that's the calculation we'll be sticking with most for what we do is the 3.14. So that's something you definitely want to remember. All right, Destiny, yeah, we will see you on Monday. So when you're calculating the surface and the area of a circle, we'll definitely need this value of pi. And then you will either need the diameter or you will need the radius, one of those numbers to work with this. And then here's your formula for the circumference. Now for this one, guys, unlike the perimeter where you just add all the sides of your polygon together, for a circle, we will definitely need to work with the formula. So depending on, are you using the diameter or the radius? If you're using the diameter, then it's just pi times d. If you are using the radius, then you will actually need to do 2 pi r for the circumference. So, it just depends on what information is given to you or what you're comfortable with. Normally, when we talk about the circumference formula, we honestly only stick with the 2 pi r, but the pi d also works. So you can see examples over here. They're giving us the diameter in this first example. So obviously, since they're giving us the diameter, you will just take pi multiplied by the 7 inches. And if you want the exact answer, then you just leave it as, 7 pi, and this will be in inches. If they wanted the approximate, then you would actually do so this would be the exact answer. For the approximate answer, you would take 7 multiplied with pi, or, take 7 multiplied by 3.14, and then whatever your answer comes out to be, that would be an approximate answer. So they show you examples with both exact and approximate. So you can see with the exact, we leave it as 7 pi, and then your inches is the unit of measurement. If you wanted an approximate answer, then you can see they took your diameter of 6.2 multiplied by 3.14, and approximately our circumference. And remember, the circumference is this length we are talking about here. Comes out to be 19.648. When it was the exact one, of course, this guy came out to be 7 pi. So that's the difference between your exact answer and approximate answer. So we'll be looking at these sort of examples in My Open Math. So the homework for this will be in My Open Math. And I have already put some problems in there, but I'm just making sure those are the ones I want to keep. So I'll fix that, clean it up, and you guys should be able to work on it hopefully here in the next couple days, if not by Monday. So we'll look at some examples for circles, and then I kind of wanted to get into some of these shapes also, because like I said, in real life, we don't always get neat, rectangles, squares, and circles to work with. So we'll look at some of these types of examples and do some more in here. So that's kind of what our next class will be, is working on these geometric problems, and then we'll talk about how to estimate cost once we know what our area or perimeter or volume, one of those measurements end up looking like. So any questions, guys, before we let you go for today? All right, so just remember, if you have not finished submitting your set theory family cottontail example, that's due tonight at midnight. And then your new homework assignment is going to be the application for percentages, which will be due next Friday. And again, if you have any questions, we'll definitely answer that on Monday. All right, guys, have a wonderful weekend. Stay safe, everyone, and I will see you on Monday morning. So have a good weekend, people. Take care. Sabrina, are you talking about the application of percentages or are you talking about the geometry example?